Good evening, my YouTube viewers. In this particular video, what we're going to talk about is some more experimental design. And on the experimental design, we're going to talk about some randomized controlled trials, and we're going to evaluate the effectiveness of interventions of educational programs by comparing treated and untreated groups. And we're going to do that by writing a program in Python. And so in order to write the program in Python, what we need to do is we need to import some libraries that are necessary to execute the program. So the first library that we're going to import is NumPy as NP, which is a numeric library that also creates NumPy arrays. And secondly, we're going to import pandas as PD, which is a data processing library that also imports data frames and series. The third thing we're going to import is matplotlib.pyplot as PLT, which is a visualization library. And fourthly, from scipy.stats, we're going to import test_ind. So SciPy is a scientific library of Python, and stats is a statistical module in SciPy. And test.ind is the function that we're going to be using. So we're going to be performing a t-test, but we're going to be performing it on samples that are not related, that are independent. So then the next thing we're going to do is we're going to simulate some data. And the first thing that we're going to do with regard to simulating the data is we're going to set our seed, because it's necessary to set the seed to make sure that the program works the same every time you run it. And what happens is when you set the seed, every time you run the program, the variables will be set up to these same values. So you set the seed by typing np.random.seed and any number you want within the brackets. Then we set the number of participants to 100. And now we're going to generate some test scores for the treated group. And this is the group of people that were in the program. So they're part of the treated group, the variant. So the treated group equals np.random.normal bracket 75, 10, n participants floor 2. So basically what you're creating is a normal distribution with a mean of 75, a standard deviation of 10, and 50 participants. And then the next group of people we're going to talk about create is data on the untreated group, which is the control group. So the untreated group equals np.random.normal, which is a normal distribution, bracket 65, 12, n participants floor 2. So that means you're having a normal distribution that has a mean of 65, standard deviation of 12, and 50 participants. So you have a sample size of 50. So you can see already that the treated group has a higher mean than the untreated group. But we will go ahead and continue with the program and see what happens. So now we're going to take the data and we're going to combine it into a data frame using pandas. So data equals pd.dataframe and then brackets, and group is going to be treated times the length of the treated group plus untreated times the length of the untreated group, and comma, and the test score is np.concatenate brackets treated group, comma, untreated group. And so now what we're going to do is we're going to calculate the summary statistics. So summary equals data.group by brackets group, square brackets test score dot agg, which means aggregate, brackets mean, comma, std. And we're going to perform an independent t-test. So t-stat, comma, p-value equals t-test_ind brackets treated group, comma, untreated group. So we're going to print the results. We're going to print the summary statistics and the statistical test results of the t-statistic and the p-value. So what we're going to do is we're going to go down to the bottom of the cell, and the group, you've got the mean and the standard deviation. So the treated group has a mean of 72.7 and a standard deviation of 9.33, and the untreated group has a mean of 65.2 and a standard deviation of 10.49. So you can see right now the mean of the treated group is about 7 points higher than the mean of the untreated group, or close to 8 points higher really than the mean of the untreated group. So you can see right here the means are higher. And then with the statistical test results, you've got a t-statistic of 3.792 and you have a p-value of 0. And so when you do hypothesis testing, the null hypothesis is that there is no significant difference between the readings, and the alternate hypothesis is there is a significant difference between the readings. So the result is the education program had a statistically significant impact on test scores. So that means because the p-value was less than 0.05, it had to reject the null hypothesis and accept the alternate hypothesis. But we'll go back to the program and continue with the code. And then so basically it's what I just said. If p-value is less than 0.05, the result is the education program had a statistically significant impact on test scores. And so now what we're going to do is we're going to plot the results using Matplotlib. So plt.figure brackets fig size equals 6, 4. We're going to create a bar chart of mean test scores. Mean scores equals summary mean. Standard deviation equals summary STD. And mean scores dot plot brackets kind equals bar, comma YERR equals standard deviation, comma cap size equals 5, comma color equals blue and orange, comma alpha equals 0.75. And so now we're going to customize the chart. The title is RCT Result Impact of Educational Program. The Y label is mean test scores. The X label is group. The grid has an axis of Y, comma line style of dash, comma alpha of 0.7. So now what we're going to do is we're going to annotate, put some code in to put the numbers on top of the bar in the chart. And then we're going to plt.typeLayout and pld.show to show the chart. So here's the chart that we have. It's RCT results, impact on educational program. So you can see that the mean for the treated group is higher than the mean for the untreated group. So what that would tell someone who was studying this is that they should go ahead and go with the treated group, because the treated group is going to give you a higher score than the untreated group. So that concludes this video. The next video is going to be on some more statistical topics. So I hope you decide to watch it, and I will communicate with you then.